In this particular class, I want us to look into electricity, that is alternative to practical electricity. This is a guide to, this will also guide you on how to um, perform a practical experiment on electricity, specifically on using potentiometer and other equipment there to determine the effect of length, that is effect of length of wire on resistance of a wire, and how it affects the flow of current in a circuit like this using potentiometer. Now let's quickly look at the information on the board. Look at this. You have this device is the potentiometer. It has a meter rule of 0 to 100 centimeter, and we are given point PC as the length of the potentiometer, which is the meter rule. Then we have the, from P to P here, shows the point of touch of the jockey on the wire on the potentiometer. There's a wire on this potentiometer on this meter rule, measured from 0 to 100 centimeter. Then these lines here are wires. In a circuit diagram, the lines here are wires. This is the circuit. In this circuit, we have, it is connected to 3 volts. But that's 2 dry cells, 2 battery, like this Tiger battery, 2, each is 1.5 volts, like 2 is 3 volts. It's okay for that experiment. Then, this is the resistor, a standard resistor of 2 ohm. Then this is the ammeter. The ammeter is for reading the current. Then, this is the key, the switch for opening and closing the circuit. Then this is the jockey. This is the jockey. The jockey is used as a conductor for completing the circuit, for as a point of contact with the circuit, that is jockey. Now, so this is the connection. Now you see this is the wires connecting this device, the components of the circuit. So now when you close the key after connection and they tap the jockey on any point of the wire, the length of wire here, then you have the reading of the current here. So theoretically and experimentally also, it's observed that in such experiment, that as the length of the wire increases, there's a decrease in the current. This is one thing you should know, which means from factors that affect the resistance of a wire. Remember that resistance is the opposition to flow of current in the circuit. So the wire has its own resistance, and one of the factors that affect the resistance of a wire is the length of the wire, such that R is proportional to length, which means as the length of the wire increases, the resistance increases. And from the Ohm's law, we know that V is proportional to what? Current, such that V is equal to IR. We are aware of this. So in this condition, if V is equal to IR, we should know that in terms of current and resistance, that current opposes the flow of what? Resistance. What does it mean? We can see that I here is equals V over R. So from this relationship, you see that I is inverse to R. So the higher the resistance in that circuit, the lower the current. That is it. So as we are increasing the length of the wire, that the length of the tapping of the jockey, the current will be decreasing in line with this Ohm's law, and the resistance increases in line with this length of the wire, while the current diminishes as being read by the ammeter. So let's look at this. So from the analysis, from the information on the board, the result on the board here, as we turn alternative to practical, because we are not carrying it live here, so we have that the length of wire. So when the jockey was tapped, from the information on the board, when the jockey was tapped on 10, then the current is 0.8 ampere, 0.8 ampere. So when the jockey was at 10 cm on this potentiometer, the current was 0.8 ampere. From this exemplary information on the board, it may not be the accurate reading for real practical analysis, but this is how to give this as information as a guide, which you can verify by experiment or practical analysis. Then from the information you have that when it was 10, this is 0.80 ampere. Remember that the unit of current is ampere, the length is in centimeter. Then the question here, we're asked to read and record the values of the L and I from this information given. We are asked to evaluate I inverse and plot the graph of L against I inverse. then to determine the slope and the intercept on L-axis, then to state two precautions taken that could be taken in such experiment. Okay, now we have that when L is 10, this one is 0.8 ampere. Then when L is 20 cm, that when the jockey is at 20 cm, then the current reaches 0.70 ampere. You see the length is increasing, resistance is increasing, and the current is what? Reducing. So you see the relationship between this and this. So then when L is 30 cm, the current reaches 0.6. That's the meaning of this diagram. We're interpreting this information. 0.6. Then when L is at 40 cm, the current reaches 0. This 40, this is for this, 0.5. When L is at 50, the current reaches 0.4. This one is for this. Accordingly, when L is at 60, the current reaches 0.3 ampere. So that's what you are seeing here. So this is for 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's what we have here as the result. So looking at this result, then this is evaluated with calculator. You use your calculator now and evaluate I inverse. I inverse means 1 over I. Now what it means, 1 over I. I inverse means 1 over I. 1 divided by this, you get this. 1 divided by this, you get this. Or use your calculator, the inverse key. That is, you have x power minus 1 in your calculator and compute this. So I inverse means reciprocal of this current. 1 over 1 is 0.8. 1 over this gives you 1 over this gives you 1 over this. 1 over the current. Or they use your key in this thing and press your value of this inverse key of the calculator. It will give you all this. So, and remember, we record this in 2 decimal places. You can see 2 decimal places. They will record this one in 3 decimal places. That's the normal experimental record. 3 decimal places here. You have to go to 3 decimal places. Then this E is the EMF of this cell or the battery. The EMF of the battery in the circuit is 3 volts, which is for 2 dry cells. That the 2 full dry cells. Okay, now from this now we are asked to do something here. Having done this, we are asked to read and record. We have done that. Asked to evaluate and plot a graph of L against X, I inverse. So for the graph of L against I inverse, it will give you something like this. Something like this. You have here as the origin. You start from the origin. So this is L in centimeter. You put the unit. L against I inverse, which means L will be the vertical and I inverse will be the horizontal, starting from the origin. If you are asked to plot I inverse against L, the first one will come as the vertical, the other one is the horizontal. So here is I inverse with the unit ampere inverse. So we have this. So from here you can choose a scale here, reasonable scale. You can choose something like maybe 20, 40, 60, 80, 100. You can see the interval like 2 cm. So here one can choose 2 cm to represent the highest value here is 60. So when you choose 20, 40, 60, 80, you can accommodate 100. So here the highest value here is 3.3 from the analysis we have on the board. So being 3.3 as the highest value, we can comfortably choose 2 cm to represent 1, 2, 3, 1.0, 2.0, 3.0, 4.0, 5.0, so and so on, maybe and so on. You can see that this can, because the highest value is 3.3, so 5.0 has taken care of this. Then while we reduce this one, you can choose 10, 20, 30, 40. But why isn't 20, 40, 60? Sometimes they will ask you for intercept. So you'll be able to get the value of your intercept. That's why you reduce this scale. Otherwise, you can spread it with 10, 20, 30, 40, and so on. Now, so sometimes the value can come to this is the negative axis of this. So this minus 20, minus 40. You see it, because this is the origin, negative value. Then, if you can plot this now, in plotting this graph, when it is 10, this is 1.25. The 1.25, we have 10 against maybe 1.25, which is approximately 1.3. So somewhere here, maybe 1.3, you plot your graph. We use small cross for graph, not star, not asterisk, not shading. Not shading. You can use small cross like this, which stands for vertical versus horizontal to be thick. Then you have I have a 20. Sorry, first of all is 10. So 10 against 1.2 for 10 should be somewhere here, half of this. You know, I'm just minimizing, I'm just managing this space. But in your graph space, you have to spread out. So 20 against 1.4. So I have 20 against 1.4 somewhere here. Yeah, you have 30 against 1.6 somewhere here. 30 will be between, of course, you know that 10 is between 0 and 20. 30 is between 20 and 40. So I have 30 against 1.6. So against 1.7 approximately, which is somewhere here. So that here is my 2. Somewhere here. So you have 50 against 2. You have 40 against 2.0. So you have 40 here against 2.0. 40 against 2.0 somewhere here. So you plot your graph, have 50 against, I have 50 here against 2.5. 2.5 should be between 2 and 3. 2.5. So you have 60 against 3.3. So you have 60 here against 3.3. Against 3.3. That's somewhere here. So you have something like this. Then you have your line. You can now make your straight line on the point that enters. Make your straight line on the point that enters. So your straight line. So this is your line. The point I want to make here, the line must not pass. Maybe all of them may not enter. Maybe some may be out. Some may enter. Some may be out. Some may enter. So when you plot such a graph, it is not a must that all the points will enter. And not a must that your line must pass through the origin. It depends on what you have in your experiment, the result you have. So this is just this is an example. In your graph, you have space enough for that. So from this interpretation, the slope here now, you take point. You take point for your slope. You take point. This is your slope. So for slope, you have something like this as your slope. So this is delta L. This is delta I inverse. So that's your slope. So for your slope now, you look at so in your point, you draw the line based on the points of line of base feet. Then you make a large rectangle triangle for your slope, considering the readable point, considering easy readable point for yourself. For example, I want to use this place. So from this question on this graph now, exemplary graph, you can see that my slope. So slope S equals delta L over delta I inverse, which is my delta L is here is 100. I have 100 minus here is 20 minus 20 all over. I read down here, I have what? 4.0 minus, if I read here is about, let me take here to be 1.5. 1.5. This is just a sketch. I'm not using this to interpret how to take slope. This is not the accurate value from this because I did not use graph here. I just use sketch here. So you can't use this to judge the exact value of this graph when plotted using a graph. So this is just an interpretation, a guide, a hint on how to take slope from a graph. So this is a sketch. So this may not represent the accurate slope of such a graph when plotted, but it will give you a hint when you now use a real graph for that analysis. So from my own sketch here, so the slope is delta, change in this axis, vertical axis, over change in horizontal axis. So for my this exemplary graph here, I have from here to here is about 1.5 approximately. You know, it's a sketch. Here is at 4. So here is 100. Here leads to 20. So I now take it to the what? Here, 100 here minus 20 here, where this one intersects. Then all over here, 4.0 minus here, which I take as 1.5, will give me the slope. So use your calculator now. So if this is my case, I have about 80 over, this will be 2.5. So how about 80 over 2.5? When you now divide, you get the value of your slope. So which will give you, this is just to give you a hint. Then I don't want to write the value here because it may not represent the exact value here, but this is just an analysis, an interpretation, a guide. Now, this is how to take slope. Then you get your value when you do the exact ray graph plotting. You can try with this value for your plotting of graph to get an idea of what I mean here. So then we now have, we are asked to find the intercept on L axis. Intercept on L axis means where this straight line, and this line must be straight line, where this straight line passes through this axis, that's the intercept. Where this straight line meets this axis. If you are asked to find the intercept on I inverse axis, it means where this line passes here, that's the intercept. So the intercept on L axis, from my own graph here, from this sketch graph, the intercept, so you call that intercept C on L axis is equals to, I have minus 20 here. Have minus 20. So that's it, minus 20. That's the intercept. So on this, based on this sketch I use, then assume that I'm asked to find the intercept on x inverse axis. It means where this straight line cut x inverse axis. It means the value of I inverse axis. It means the value of I inverse when L is 0. That's another language. So if you are asked to find the value of I inverse when L is 0, it means the intercept on I inverse. And from my reading here, it will be 1.0. You can see it here, it can see 1.0. So if but now the question asks me for intercept on L axis. It simply means in another language, the value of L axis, the value of L when I inverse is 0. That is it, which is this place. And have minus 20. So for you to know how to get intercept. So intercept on any axis means where the straight line meets that axis. The reading of that value is the intercept. Then another question is still 2 precautions taken. What are the precautions that could have been taken to get accurate result in this experiment? Because it is electricity, one of the precautions you could take is you ensure that the connections are tightly made. So I ensured tight connections of the circuit to avoid partial contact. Because when the circuit, the wires, the components are not well connected or tightly connected, there might be partial contact and there might not be a current flow. So I ensure tight connection of the circuit to avoid what? Partial contact. Another precaution one could take to ensure accurate result in this experiment is in terms of reading. When reading from that ammeter and the meter rule of the potentiometer, you should be careful to avoid error. So one can say that I avoided parallax error. I avoided parallax error when taking reading on the what? Ammeter and the meter of the potentiometer. When taking reading from the ammeter and the potentiometer. So that can be another precaution then. So another precaution one could take to ensure accurate results in this experiment when practically done is I removed the key or I opened the circuit. You know, the key or the switch is for opening and closing the circuit. So I opened the key or I removed the key or I opened the circuit when reading is not being taken. So you have to open the circuit when reading is not being taken to avoid what the essence of opening the circuit, to avoid what? Running down the cell or battery. To avoid running down the cell or battery, or to avoid heating of the wire, which increases the what? Resistance, thereby altering the result. So with this explanation and guide, I believe you can now carry experiment comfortably using potentiometer and with respect to measure the effect of resistance on the what? On current flow, which is also indirectly in line with Ohm's law. Thank you so much. And you see how the result should look like, that as the length is increasing, the resistance will be increasing and the current will be decreasing. Thank you so much. And how to make evaluation how to plot graph, how to choose scale, factors to consider when choosing scale, and how to determine your slope from scale and interpret your intercept. Thank you so much for attention to this class. I believe with this you can do excellently in practical analysis of this nature. God bless you. For more of these solutions in physics and the chemistry and guide even in practicals, physics and mathematics, I mean, solutions and guiding practicals as well, you can reach out to me through my contact here, and for your online classes through Zoom, Telegram,